So here we are going to discuss about a new topic which is called structures in C. C supports a constructed data type known as structure. It is a mechanism for packing a collection of different data items of different types using a single name. It is generally used to store logically related data items. Okay, we already studied about arrays. Array contain a number of cells. Suppose it is int a, that means a is an integer array. Each and every cell we can store some integer value. Each and every cells can store some integer value. Here I can't store some character value. So this is the speciality of array. It is a homogeneous collection of data items. So here we just read the second point. It is a mechanism for packing a collection of different data items of different types using a single name. Here in array what happened? We are storing different data items of same type using a single name. Name means A. Here each and every cell will contain same data type. The elements will be of same data type. But in structure what it is possible, we can pack different data items of different types of different data types using a single name. That is called structure. It is generally used to store logically related data items. So how to define a structure? So first we have to use a keyword called struct. Struct is a keyword. Then you have to give a structure tag. Structure tag means it is an identifier. You can give any name, but you have to follow the rules of identifier. Then you have to give data type member 1, data type member 2, etc. This data type may be different. First one may be integer, second one may be character, or something like that. Okay. I'll try to explain with the help of an example. Suppose I want to read some student data. Student data means name, roll number and mark. Other data are also there, date of birth, address, year of admission. Those things are also related to student. Here in this example I am only storing name. I am only concerned with name, roll number and mark. We all know name is a string because it contains more than one character. So since it is a string, we have to use a character array. Then to store roll number, I have to use a integer variable. Then to store mark, I have to use another integer variable. So if you look at this one, these are all related data items. When we think about a student, name, roll number, mark, everything is related. Because everything has a meaning. These all things are related to student. That's why structure is generally used to store logically related data items. So anybody have any doubt in this slide? If you have any doubt, please ask. Okay. So things to remember is struct is the keyword. Then you can give any identifier, that is called structure tag. Inside that you have to define the members. Already told you you can store different data items of different types. So those different types must be listed inside this structure. So one more thing you have to careful is there is a opening braces and closing braces. After that there is a semicolon. Here also there is a semicolon. So I'm moving to next slide. Declaring structure variables. So one method is again you have to use the keyword struct. You have to mention the structure tag. Then you have to give identifier 1, identifier 2, or up to identifier n. You can use any number of identifiers. For example, we already defined one structure called student. You can declare student like struct stud s1, s2, s3 or sn. So you just think I have implemented the statement or executed this statement. So declaration means allotting some space, or we all know int a means to store a, it will allocate some space, and that space will have some address, and also that space is having a name that is actually a. So similarly, structure is also a user-defined data type. Here I am declaring it struct stud s1. So some space will be allocated to store s1. So what is s1? S1 is not an integer. S1 is student. What is student? Student contain a character array of size 10, an integer variable of and 2 integer variables. So here 10 cells will be there. Each cells can store character. Since each and every character takes 1 byte, already studied, the size of character is 1 byte. Since each character take 10 bytes, this character name will take totally of 10 bytes. Since each character take 1 bytes, total, and the name will take a total of 10 bytes. So suppose this is the memory representation. So first 10 bytes are allocated for name, and some address are also there to each bytes. Then I have int roll number. We already studied. Integer has 4 bytes. So it will change based on system architecture. You just assume I have 4 bytes of integer. I will get 4 bytes to store an integer. So another 4 bytes which represent roll number. Similarly, here I have int mark, another 4 bytes which represent mark. So the entire thing can be considered as a variable. That is S1. What I declared is S1. So a total of this much memory. Here actually it is 18 bytes will be allocated. For S1 alone, 18 bytes will be allocated. First 10 bytes are used to store the name. Next 4 bytes are used to store the roll number. Next 4 bytes are used to store the mark. So you have to understand the difference between declaring a variable and also declaring a structure variable. So if I write something like only int mark, the meaning is it will only have this space. So since this is a structure, it has some members. 3 members are here. So if I declare something like struct stud s1, this much of memory will be allocated, or it will be reserved for storing that structure variable s1. If you have any doubt, you can ask. Otherwise, please respond with a clear message. Sham Santosh.
Yes, sir.
Any doubt?
Yes, sir. Mansley.
Okay. So I'm getting only few responses. If you have any doubt, please ask it openly. If you have any doubt in any of the points, please ask it. Mayangraj.
No, sir.
Any doubts?
No, sir.
Okay. Okay, this is one way of declaring structure variable. Another way is also there. So here, this one is the definition part. We already studied about that. This one is the definition part. Along with the definition, before that semicolon also, you can declare the variables. S1, S2, S3 up to Sn. Here also you can declare. another method is also there. If I declare it along with the definition, even we can avoid this structure name. Even we can avoid this structure tag. Because by looking at S1, we know S1 can store a string, it can store a roll number, it can store a mark. S2 can store a roll number, mark and name. So here we can avoid that structure tag. So when we do declaration along with the definition, we can even avoid that structure tag. The proper place for structure declaration is in the global area of the program before main. So this will be clear when we write the program. Structure initialization. First one is compile time initialization. Struct stud S1 Smith 49, 100. So S1 is a structure variable and this much space will be allocated. So first 10 bytes are for storing name. So here I have given name as Smith. So here S will come, here M will come, here I will come, here T will come, here H will come, here a /0 will come because it is a string. Then in place of roll number 49 will be stored. Here 49 will be stored. Here 100 will be stored. This is compile time initialization. During the time of the compilation itself, the program knows the values of structure variable. Structure variable means every structure variable will contain some fields. When we are storing some value, we have to store it separately. Okay. Let me move to next slide. So,
Sir,
okay, what's the doubt?
so what if there is large number of students?
Okay, that we will study. Here I am only dealing with one student. So I understood your question. What Mayank is asking is, what happens if there is some 100 students or some 50 students? So that we will study later. Today itself we will study. Okay. Accessing structure variable. So the individual members of a structure can be accessed using dot operator. It is also called member access operator. So here, if I have a structure variable S1, if I want to read the name, I will use S1 dot name. From the structure variable S1, if I want to read the roll number or I want to store something to roll number, I will use something like S1 dot roll number. So structure variable followed by a dot followed by the member name. So here name, roll number, mark, all are members. So dot operator is used to access structure variable. Anyway, these things will be clear when we see the example. Okay, right. So here I have some exercise. Write a program to read and display details of a student. Read and display details of a student. So here I only read storing one student, so I am just giving one stud details dot c. Say. So you just keep this point in mind. The proper place for structure declarations is in the global area of the student before main. So before main, I have to define the structure. So here I am going to store some student data. So first I am going to define the structure. So keyword is struct. So I am giving a tag struct student. 3 members are there, char, name of sub 10. int roll number, int mark. So here you have to put a semicolon. So that is included. Now I am writing the main function. Main. So anyway, I am going to read details of a student. So I have to declare a student variable. I have to declare a student variable. So declaration is done by struct student s1. So when I write this statement, some space will be allocated in memory, which can hold name, roll number, and mark. This entire block is called S1. This entire block is called S1. Next, printf. Enter name, roll number, mark, enter name, roll number, mark. So I have to use some enter name, roll number, mark. So here I am using some scanf statement. Scanf. So since the first name is a string, I am using percentages. Then roll number, it is an integer, so percentage %d. Again an integer, so percentage %d, comma. Since it is percentages, no need to give ampersand name. So I am just writing name, comma. Sorry. Where I had to store it? I had to store it in S1. In S1, where I had to store? In name. So I am giving S1 dot name, comma. So here generally when we use scanf statement, we will put an ampersand symbol. Here I am not putting that ampersand symbol because name is a string. In string, that ampersand symbol is not required. It is not mandatory. Even if you write it, it is not wrong. So then ampersand S1 comma, sorry, S1 dot
Sir,
in, okay, tell.
sir, in string scanf statement means we can store only one word only, na, sir. Then we can
Anyway,
write.
put us. Okay, you can either write put us also. Then you have to enter it separately. First you have to enter name, then you have to read roll number and mark. So after completing the program, I will modify it. Okay. Using put us. Sorry, using get us, comma. Again, I have to read a mark in S1. So ampersand S1 dot mark. So here, okay, some problems may arise because here I am reading a string then followed by an integer. So let me do it. Okay, after that we will discuss. Then printf percentages, I am giving a /t, percentages, sorry, percentage %d. Again, I'm going to give a /t, percentage %d, comma, S1 dot name, comma, S1 dot roll number, comma, S1 dot mark. So let me execute the program. Name, I'm giving Rohit, roll number 45, mark some 120. So here it is printed Rohit 45 120. So what is happening here? Enter name, roll number, mark. I have entered Rohit 45 and 120. It is S1 dot roll number. So in S1 under name Rohit will be stored. Then I entered 45, S1 under roll number 45 will be stored. Then S1 under mark 120 will be stored. Then those values are printed. Any doubt in this program you can ask. So here if you write putters using putters, you have to modify this program. So first you have to enter that name. Then get us of S1 dot name. Then enter roll number, mark. Then S1 dot roll number, comma S1 dot mark. This also will work. Rohit 45 to 10. Okay, sorry. First it is asked to enter name Rohit, then roll number and name 45 and to 10. So in this way also you can write. Anyway, I'm going to change it in the previous format. Okay. So any doubt in this program? So one more point we have studied. This is the structure declaration. Declaration can be done along with the structure definition also. So here you can simply write S1. This one also will work. So here we have studied declaration can be done along with the definition also. So let me execute the program. Name, roll number and mark. Rohit 45 456. So it is working. One more thing we have studied. When we declare the structure variable along with the definition, we can even avoid that. We can even eliminate that, or we can even remove that structure tag. So let me execute that program again. Smith 4978. So it is also working. So these are the 3 points we have studied. So anyway, it is a very good practice to give structure name. Okay. So first one is finished. Next one is write a program to perform addition of two complex numbers. Addition of two complex numbers. So we know how to add two normal numbers by declaring two variables. But complex numbers has two parts, a real part and a imaginary part. So we have to define a structure called complex. In that we have to write two numbers, int real and int img, and we have to proceed the program like that. So anyway, I will write the program. Add complex dot c. Save. So first I am defining a structure. Struct complex int real int img, and I'm putting a semicolon. So anyway, I'm going to add two complex numbers. So how many complex numbers are required? Anyway, two complex numbers to store the values, and one more complex variable is used to store the result. So I'm declaring three variables: s, comma, s to store the sum, a to store the first complex number, and b to store the second complex number. So I am declaring it along with the definition. Main printf enter real and imaginary part of first complex number. Scanf so it will be two integers, %d, comma Nuja MB.
Yes, sir.
So what I will write next? So first complex number has to be stored in A. That real part has to be stored in real, and img has to stored in img. So what will I write?
Percent,
Nuja.
ampersand,
Okay, ampersand. Then
ampersand A,
A. Then
ampersand B,
ampersand A. If it is A is not an integer variable, it is a structure variable. Structure with name complex. So in A under real I have to store that the first integer value. In A under real I have to store the first integer value. So what I have to write? I can't write A. So just all I have written now. So here student S1. For name I used S1 dot name. Student S1. To store roll number I have used S1 dot roll number. So what will I have to write it here? Nuja. Ampersand A dot.
A dot real.
Okay, A dot real. ശ്രദ്ധിച്ചിരിക്കാത്തതുകൊണ്ടാണ് കേട്ടോ. So what I will write next?
B dot complex, ampersand B.
B is a second number. Here first number also contain a real part and an imaginary part. So what I will write?
Ampersand A dot imagine.
ഒന്നും ശ്രദ്ധിച്ചിട്ടില്ല കേട്ടോ ഇന്ന്. img. Okay. So similarly I have to read the second complex number. So it is B dot real and B dot img. Then I have to find the sum. How to find the sum? S dot sum dot real equal to Deepak.
Yes, sir.
What will I write? S dot real equal to
Storage is equal to A dot real
A dot real
plus B dot real.
plus B dot
Real.
real. Anu Fasmin. Anu. What will be the next statement? So I think your mic is not working. Anna,
Yes, sir.
what will be the next statement? This is real
Imagine.
part. Okay.
Okay.
So what I will write?
S dot imaginary.
S dot img equal to A dot
A
img
plus
plus B dot img. Then I have to print the sum. Printf. So while studying quadratic, we studied how to print imaginary numbers. Sum equal to %d plus I %d. Here I am putting a slash n, comma s dot real, comma s dot img. We execute the program. I'm giving 5 and 10. Second number I am giving 7 and 9. So the expected result will be 5 plus 7 is 12. 10 plus 9 is 19. 12 plus I90. So I got 12 plus I90. Any doubt in this program? Okay. Moving to the next subtopic. So 2 exercises are finished. Next is array of structures. So earlier we studied how to store a single student data. Suppose I want to store student data of the entire class. So actually I think Mayankraj asked the same doubt. So if I want to store a single integer, I will declare a single integer variable. If I want to store 2 integers, I will declare 2 integer variables. If I want to store 3 integers, I will declare 3 integer variables. Suppose I want 100 integer variables, I can declare 100 integer variables, but it is difficult. So there I will use a array. So here similarly we will create a structure array. So here struct stud s of 20. So index value will range from 0 to 19. Index value 0 contains 3 fields: name, roll number and mark. Similarly index value 1 will contain 3 fields: name, roll number and mark. So you just compare with a single structure variable student and also array of structure variable student. So now it looked like a table. Table means these are all related data. It can also called as a student database or student details. So this is how we will declare array of structures. Along with the variable, you have to just specify the size. Along with the variable, you have to just specify the size. Is it clear? Anyway, it will be clear when we write example. First example, write a program to read and display details of students. Details of student means student database in a class. So earlier I have read one student detail. Here I have to read n number of student details. So it is one student detail. So I will modify the program. For that I am renaming the file student details. So the structure definition will be same. But here instead of S1, I have to give some size. S of some 20. So here declaration is done along with the definition. S20 means it is of type student. Student means each and every cell can store name, roll number and mark. So here I am declaring on variable int n, printf. It is similar to reading the array. Printf, enter number of students, scanf %d, n. Then I have to write a for loop for I equal to 0, I less than n, I plus plus. So a new variable is used and declaring that variable also. Inside that I have to repeatedly execute this statement. So here enter name, roll number and mark. That will also repeatedly printed. Here I have a scanf statement. Filsa Kareem. Filsa Kareem. Fida Sahuda.
Yes, sir.
What are the changes I have to make in this statement?
Eighth step.
Yes, I want to make some changes in line number 16. What are the changes?
Size S1
S1 has to be changed to
string S of 1.
okay. Okay, you can mute the mic. Okay, no problem. So suppose I have declared an integer array. So while I am reading, I will include a for loop. Then I will write a scanf statement. Inside that what I will write %d. These things are already discussed. Comma ampersand a of I. A of I. This is how we read an array. Here I have a structure array. So when the variable is S1, here I am using S1 and S1. When it is S of 20 and it is also under a for loop with control variable I, what I have to write here is this is S of I. Similarly here also S of I. Here also S of I. Again, to print the value also I have to use a for loop. So here also instead of S1 I will write I. I. Run the program. Enter number of students. Here I am entering only some 3 students. So the program exited. because in scanf I didn't give ampersand. Okay. I'm executing the program. 3. Enter name, roll number and mark. So ASD, some random values I'm entering. 89. Again HJK, some random values I'm entering. NMB 56 123. Okay, these things are printed, but it is printed in a single line. Suppose I want to print in a multiple line, I will use a /n here, new line. So again I am executing 3 students, JKL 45 8 58 6 4 59. So now it is printed in a table format, name followed by roll number followed by mark. So it looks like a table. Suppose I want to give some column name to every table. So it contains 3 columns. Suppose I want to give some column names. So I will include one more statement. Printf /n. First field is name, then /t. Second field is roll number. Again I will give a /t. Next field is mark. Again I am entering 3 student details. So I'm just giving some random values. So now it appears like a table. So this is how a list of students has to be read, and it is printed. Any doubt?